All right, so let's go over the toString method now. Okay, so for the toString method, we need to go through the entire list and print everything out. So I'm going to make this a recursive function. I'm going to go through and do an in order so we're going to walk through this in order. So let's go ahead and do an in order traversal. That's the word I was looking for. But that will be a recursive algorithm. So we're going to actually have a private toString method, private string, which will return a string, obviously. And that will be basically, we're going to say, do a toString, turn this tree starting at root into a string. Okay. Now these things end up being actually a bit easier than you'd expect if we just want to do something basic. So this says, first off, if root equals null, let's just come up with our base case here, because we need to do a base case and then we need a recursive case, right, if we're dealing this recursively. How is a in order traversal going to work, right? We're going to go left, myself, then right. You remember that? That was like forever ago, I know. But remember, in order traversal means I'm going to traverse through my left subtree first, recursively, using the same traversal. Then I'm going to recurse through myself and then my right subtree, although, hold on, actually, let's check the video. Left, ooh, okay, no. Left, myself, and then right. Right, so reversed in this video because flips. All right, so, okay, so root. So basically, in the base case, well, what if the root is null? What if we hit a leaf? Basically, not even a leaf, but like the leaf subtree, which is null. Well, in that case, that's the string representation of that is pretty easy. It's nothing. Okay. Otherwise, if the node isn't nothing, then we want to return something else. Well, let's go ahead and basically let's go ahead and have an output. Okay, output plus equals, we're going to turn our left subtree, left, into a string, right? Then we'll turn ourselves into a string, which we'll do, let's say, by saying output plus equals toString. I need to do that. Output plus equals root.item, not toString, although that's not unnecessary. We'll automatically convert that into a string, plus a space, and then we'll just, so we do our left, and then we'll do our right. Then return output. So now we'll go down here. Okay. So, and we'll create a binary tree. Binary tree of, let's go with strings because those are easy to see. Well, they're alphabetical. Tree is equal to new binary tree. So tree dot add let's go and add hello tree dot add world add apple tree dot add zebra system dot out dot println tree, and if I print this out, it's going to print out not actually the answer, I don't think. finish this or something. What? I wrote this private recursive method, but I never called it. So return toString, turn the root of the entire string, sorry, root of the entire tree into a tree. Apple, hello world, zebra. So let's go ahead and do what about a pre-order traversal? How would I do a pre-order traversal? Well, all that involves is just basically flipping stuff around. So that means I'd do this. And we'd have to verify this answer ourselves. So hello, Apple, world, zebra. Do myself, then my left, then my right. Well, hello was the root. Then world went to the right of hello. Apple went to the left. Zebra went to the right of world. I do myself before I did my children. So it seems to work so far. We might work on a more extensive one later, but for right now it works for testing purposes. Okay, so now let's go ahead and tackle the delete method.